So according to the terminologies, our first thing that is amplitude. Amplitude is the shifting of the particle from its mean position to the maximum extent. Yes, likewise we have seen that a particle is shifting from its mean position to some particular extent. Okay, like this is the final mean, from the mean position it is the final maximum extent to this particle can be shifted according to the loudness, according to the sound that has been produced by something. Okay, if the sound is more loud, then more shifting is there. If the sound is dull, then it is shifted towards the very few distance, like very few displacement is there. Okay, so here according to the pendulum we can explain this too. Like here from O position in first case, the bob is shifting from here O to B, and then B to A, then A to O again. Okay, now you can see the displacement here is maximum. Okay, maximum, we can call it as maximum for this condition. Okay, like the gap is here more. Now see the second one here, O, B, A. Okay, now in this case also the shifting is maximum for this particular condition only. Okay, so we can say that energy required in the first case is more compared to the energy required in the second case. Okay, so here according to the judgment we can say that the amplitude produced by this A part, like first case, is more compared to the B part. Here in the same manner, if we produce more sound, then more shifting will be there, and if we produce less sound, then less shifting will be there, like this. But this we cannot treat as a mathematical representation of anything, because you know, if we want to give some theory, we should have certain proof and result related to that, and for that also we need to have clarification details, and that should be represented by graphical manner. Okay, so here we are having a graphical representation too. Fine. So, like suppose this is the mean position of a particle and this is the maximum displacement, that is we can say that amplitude, x-axis and y-axis. So, if a sound is starting from the mean position, let's suppose this is the mean position, this line, whole line is a mean position, x-axis is a mean position. Okay. Now, if it is shifting from here, mean position to the maximum extent here, that let's suppose this is the maximum extent. Okay, till then the sound can be produced, the molecule can be shifted. Okay, so here is the maximum extent. Then it again bring back to its mean position. So again it bring back to its mean position, and then you know that it after coming here, it again going to shift here. So going back to the negative direction. So here going back to the negative direction, and from here negative direction come back to the again mean position, come back to again mean position. Why we are calling this as negative direction? Because it is opposite direction of the first one. The only reason is that there is no plus and minus here. The first if we take in as positive, then the other one is definitely negative. Okay, so this is how we are calling it as the amplitude graph. Okay, and the amplitude here is shown by the height of the graph, like this. This is and this is will be equal. Fine. Now, you people are going to tell me which out of these two graphs, like one is this and another one is this, are having loud sound. Okay, this is A and this is B. Okay, so yes, definitely, yes, you are correct that this one will have loudness. Okay, because the shifting of the atom from here to here is maximum in this case. That is why it is having a loud sound. Yes, so we can also say that through this, all we can judge is that loudness is actually proportional to the amplitude. Yes, it is proportional to the amplitude, but the square of the amplitude. If we actually double this amplitude value like this, the height of the graph is going to be doubled, then the sound that is produced by any object will get 1/4 time of the produced sound. Okay, like if someone is producing L1 loudness, then afterwards when we doubled the amplitude, then the loudness will become 4 times of the previous one. Okay, and that loudness is actually calculated in the SI unit that has been given, that is decibels. Okay, so decibel is the SI unit through which we can actually calculate the loudness of any sound. Like the roaring of the lion can be heard by the farmost place, because it is too much loud that the amplitude that is produced by the lion is so much high that the sound can be traveled through a long distance, because energy is too high. So the amplitude is too high. Okay, that is why the slow sound or the weak sound is not going to be travel more distance, but if the loudness is more, it is going to be traveling more distance, because the energy dissipated here will be more through the long distance.